All right, today we're going way, way up. We're going to explore a kind of engineering that operates at the absolute edge of what's possible. I'm talking about systems that are so vital, they're basically invisible lifelines for an entire nation.
So let me ask you a question. When you hear the word ropeway or, cable car, what's the first thing that pops into your head? For most of us, it's probably something pretty familiar, right?
Yeah, you probably think of ski lifts, gliding up a snowy mountain, or maybe those scenic gondolas with the amazing views. And look, those are all about convenience, about tourism. But that's not what we're talking about today, not even close.
You see, the most critical ropeways, the really important ones, are the ones you'll probably never ever see. We're talking about massive industrial scale systems. They're built by firms like India's M&M Ropeways, and they're built out of pure absolute necessity, in places where there is literally no other way to get the job done.
And M&M's work, it's not just one thing. They've totally mastered cable technology across three incredibly different and demanding arenas. I mean, they're tackling everything from moving soldiers all the way to positioning massive 50-ton payloads. It's a huge range.
So let's break it down. You've got three main categories here. First, systems designed specifically to move people. Second, you have these industrial workhorses for hauling huge amounts of materials. And third, this is the really cool one, highly specialized cranes for precision heavy lifting. Okay, so let's start with moving people. Now, M&M does build regular tourist systems, sure, but a key client of theirs is the Indian Army. And that changes the entire game. It demands something the source material calls serious reliability. And we're not talking about just a beefed-up cable car here, no way. This is a hardened supply line. That means you've got layers and layers of redundancy in the power, in the controls, and all the mechanical parts are hardened to survive the most extreme conditions you can imagine. Because let's be honest, failure is just not an option.
All right, next up, moving materials. And this is where the scale just becomes, well, it's truly mind-blowing. Get this. M&M's industrial ropeways can move the same amount of material as hundreds of dump trucks every single hour.
I mean, just try to picture that for a second. The logistical nightmare of hundreds of trucks on the ground. You've got convoys, constant road wear, all the fuel, the noise. It's chaos. A ropeway? It just swaps all of that for one continuous automated flow. It's basically a conveyor belt in the sky. It's this perpetual motion machine for materials that can slash construction timelines. And that brings us to the third arena, precision heavy lifting. Now, this is arguably their most technically demanding work. We're talking about these highly specialized cable cranes that are used to build huge infrastructure projects like dams deep down in these totally inaccessible canyons. So it's not about just moving a lot of stuff. It's all about accuracy. You got to think of it like performing surgery, but you're using 50-ton sections of steel. So this all leads to the big technical question, right? How on earth is it possible to guarantee that kind of reliability, that kind of precision, when you're operating at the literal edge of the inhabitable world?
Okay, first, just consider the altitude. Some of these M&M installations are running at 18,000 feet. To put that in perspective, that is way higher than Everest Base Camp. At that height, you're dealing with incredible wind shear, and the air is so thin that normal diesel engines just lose power. It's a problem called derating. So just to get the thing to work, you need specialized, often turbocharged engines.
And as if that's not enough, on top of that insane altitude, you have to deal with extreme cold. We're talking systems designed to operate flawlessly all the way down to minus 35 degrees Celsius. At temperatures like that, standard steel can become as brittle as glass. And the lubricants? They can just turn into solid wax. Everything just stops. So how do you solve for that? It's pretty incredible, actually. To fight that cold-induced brittleness, they use special low-temperature alloy steels. They're fortified with elements like nickel that help them stay tough. And to keep everything moving smoothly, they use specialized synthetic lubricants that don't freeze up. And they even build heating elements right into the gearboxes. It's a total all-out war against the physics of these extreme environments. But how do clients know all this stuff actually works? Well, M&M builds everything to OITAF standards. That's the international gold standard for ropeways. It was born out of decades of European alpine expertise, so you know it's serious. OITF sets these super strict rules for things like, say, mandatory 5 times safety factors on the main cables,
plus incredibly rigorous fatigue testing. If you're building to OITF standards, you are, without a doubt, building to the highest global benchmark there is.
But look, being a technical genius isn't the whole story. To really succeed in the world of massive infrastructure, you also have to have a really savvy business strategy. And that's a huge part of M&M's competitive edge.
The first pillar of that strategy, a proven track record. I mean, over 35 years, M&M has delivered more than 120 of these projects. Now, if you're a client planning a multi-billion-dollar project, that history is everything. It's hard proof of reliability. It's basically a powerful insurance policy against the massive risks of delays and cost overruns.
So their whole strategy really rests on three key pillars. You've got that proven track record we just talked about, which inspires a ton of confidence. Then there's their complete end-to-end control over the most critical components. And finally, a really unique approach to financial flexibility for their clients.
Let's talk about that second pillar, end-to-end control. This is so smart. They strategically make the most critical components themselves, in-house. Take the sheaves. Those are the wheels the cable runs on. They are absolutely safety critical. If one of those fails, it's catastrophic. Then you have the drive units. They're precision critical. They control the movement, the stopping power. By making these parts themselves, M&M controls the quality every step of the way, from the metal they use to the final machining. It guarantees performance where you absolutely cannot afford to fail. And the third pillar, financial flexibility. Think about it. A multi-million-dollar ropeway is a huge upfront cost. That's what we call CAPEX. So what M&M does, very cleverly, is offer leasing options. This transforms that gigantic purchase into manageable monthly payments, or OPEX. Suddenly, that huge financial barrier is lowered, making these state-of-the-art systems way more accessible. And it frees up the client's own cash for other critical parts of their project.
So, okay, when you put all of this together, you've got the extreme engineering, the global standards, the super smart business strategy. What you end up with is more than just a machine. You get a solution that has a truly profound impact on fundamental national challenges.
And really, these systems deliver three major national benefits. First, they dramatically enhance safety because they automate what is easily the most dangerous part of high-altitude logistics. Second, they have a much, much greener footprint than a constant parade of truck convoys. And third, and this is crucial, these serve as a vital link for national security.
And to really get that national security point, you have to understand this. Many of India's high-altitude border roads, they're seasonal. They get completely shut down by snow for half the year, totally cutting off remote outposts. A ropeway just bypasses all that chaos on the ground. It gives you a permanent, reliable, all-weather connection. It transforms an isolated outpost that's cut off for 6 months into one that's connected 365 days a year. That is a massive, massive strategic advantage.
So, we've come full circle, right? From simple tourist gondolas all the way to vital national assets. And that leaves us with one final thought to chew on. We usually think of critical infrastructure as stuff that's fixed firmly to the ground. Roads, bridges, railways. But what we're seeing here is that some of the most reliable, most advanced logistical links are literally just hanging in the air. So if our most critical supply lines now depend on these invisible threads, what does that really tell us about the resilience of our modern world?